we will be emphasizing on the temperature dependence of reaction rate and Arrhenius equation. So one thing we know is that the kinetic energy of a gas is directly proportional to its temperature. So what we are saying is that as the temperature increases, what that means is that there will be more collisions, and so the rate of reaction should also go up. So in some years ago, Arrhenius suggested a very simple relationship that relates K and temperature of the system. And the equation in basic term is K is equal to A EA over RT. So A is determined experimentally, and then we know EA is the activation, energy, R is the gas constant, and T is temperature in Kelvin. So if we take the natural logs of each side of the Arrhenius equation, then it will be natural log of K is equal to minus EA over RT plus natural log of A. This becomes our equation 2. This is our equation 1. If we write it log to the base of 10, then it will be log of K is equal to minus EA over RT plus log of A. If we take activation energy, which we don't know, but we take the gas constant at standard temperature, or if we basically, sorry, not do that, but if we use the logs instead of the natural log, then this will become log of K is equal to minus EA 2.303 RT plus log of A. So this becomes our equation number 3. So if we are comparing two constant at two temperatures, so that if we have K1, K2, they are rate constants at T1 and T2 respectively, we can combine the two equations, and basically when you derive it, it should give you log of K2 over K1 is equal to EA over 2.303 R into bracket T2 minus T1 over T1 T2, and this is equation number 4. So Arrhenius equation is valuable because it can be used to calculate the activation energy if the experimental value of our rate constants are given. Okay, so we can basically represent the Arrhenius equation graphically. So we can rearrange this so that we have ln k is equal to minus EA over R in bracket 1 over T, the same as EA over RT, plus natural log of A. So this is y equals to mx and then plus b. So this is an equation of a straight line in the form of y is equal to mx plus b. So the two variables in this equation, the two things that you'll be able to plot are natural log of k and the reciprocal of temperature. So we can then plot the natural log of k again is 1 over t, so that we have that natural log of k, and then we have 1 over t. If we plot it, the line should come like that. And so if you're to get the gradient, then we have delta ln k and then change in 1 over t. And so the slope will be equal to change in ln k over change in 1 over t. So this is how we can plot. So if you're given various values, you can be able to then determine a plot, and this can help you to get your slope, and then you calculate backwards and use the Arrhenius equation to get whatever the question expects you to determine. So if you look at your textbook, there are solved problems that are meant to help you in your exercises. So as we come to the end of the topic of kinetics, can you look at some of those solved problems and see if you can relate it to the formulas and the expressions that we have just indicated? Otherwise, that marks the end of the topic. And so in our next class, we will start looking at phase equilibrium. Thank you.